Welcome back to AllAboutRx. Today, we are breaking down the urinary system. Whether you're prepping for pharmacology or physiology exams, or you're just a focused learner wanting a deeper look at how your body works, understanding how we process waste is absolutely essential. We've got a lot of ground to cover today, so we're keeping things fast-paced and high-yield as we explore our body's ultimate biochemical filtration plant.
Okay, let's take a quick look at our roadmap. We'll be covering the renal filtration plant, the four pillars of the system, inside the kidney, the nephron pathway, storage and voiding control, and finally, a quick recall summary.
Let's jump right into Section 1, the renal filtration plant.
Now, before we look at the individual parts, we really need to nail down the primary goal of this entire system. The renal system isn't just a basic waste disposal unit, It's an incredibly complex filtration plant. It doesn't just get rid of toxins, it actively balances our internal chemistry by removing excess water and salt while reclaiming essential nutrients. Why does this matter? Well, it's all about homeostasis. It's separating the harmful metabolic waste from the vital vitamins, minerals, and proteins that need to go back into your bloodstream because, quite frankly, our body desperately needs them.
Moving right along to Section 2, the four pillars. The entire architecture of this highly efficient system is built upon four main structural pillars. We have two kidneys, which act as the functional core, where blood is filtered and urine is actually formed. Then we have two ureters. These are the transport tubes that carry urine away from the kidneys. Next is a single bladder, essentially a muscular sac for temporary storage. And finally, a single urethra, the final exit point carrying urine right out of the body. If we trace the macro path of the system, blood enters the kidneys way up at the renal arteries. From there, filtration happens, and the resulting urine travels down those long, thin ureters into the urinary bladder, which sits right above the pubic symphysis, before finally exiting through the urethra. You'll also notice a really important comparative anatomy note here between the male and female systems. Specifically in males, the urethra actually passes straight through the prostate gland.
All right, let's zoom in a bit for Section 3, inside the kidney.
Shifting our focus to the real functional core of this operation, let's look at the kidneys themselves. Just to give you a quick anatomical anchor, these bean-shaped organs are each only about the size of your fist. You've got one on each side of your back, nestled securely just below the ribcage. And despite being relatively small, the workload they handle is, honestly, just monumental.
Get a load of this number, 113.6 to 141.95 liters. That is the staggering volume of blood that these two little fist-sized organs filter every single day. Literally dozens of liters. But what's really fascinating here is that from that massive volume of filtered blood, they only produce about 1 to 2 liters of actual urine daily. That huge discrepancy perfectly highlights just how much fluid and how many vital nutrients your kidneys are constantly reabsorbing and sending right back into your system.
So, diving beneath the surface, the outer layer is the renal cortex. This is where the microscopic workhorses, the nephrons, live. Moving inward, we hit the renal medulla, which holds these darker, triangular structures you'll hear referred to as the renal pyramids. And right at the concave center, we have the renal hilum. This is the crucial gateway. It's where the renal artery brings blood in, the renal vein takes the clean blood out, and the ureter exits to carry the urine away.
This brings us down to the micro level with Section 4, the nephron pathway. Zooming all the way in from the gross anatomy, we find the true star of the show, the nephron. It is the functional unit of the kidney. Think of it as a series of specialized segments. Every single nephron carries out 3 absolute must-haves for making urine: filtration, reabsorption, and secretion.
Let's walk through the exact journey of the filtrate step by step. Blood first enters the renal corpuscle, which is basically a starting point containing a capillary tuft called the glomerulus and a cup-shaped sac known as Bowman's capsule. Here, blood filtration starts, based purely on particle size. Next, the filtrate moves into the proximal convoluted tubule, or PCT. This is the most active site for reabsorption and secretion. Your body is aggressively reclaiming what it needs right here. Then it travels down and up the loop of Henle, which concentrates the urine, before entering the distal convoluted tubule, or DCT. The DCT receives that dilute filtrate before it finally empties into the collecting duct. And throughout this entire microscopic journey, tiny blood vessels tightly surround these tubules, perfectly positioned to snatch all those vital nutrients right back into the bloodstream.
Let's zoom back out for Section 5, storage and voiding control. Once urine leaves the kidney, it travels down the ureters. But it doesn't just passively fall by gravity. The ureters use an active transport mechanism called peristalsis. It's this rhythmic tightening and relaxing that actively pushes urine downward in small spurts roughly every 10 to 15 seconds. And a really critical clinical note for you here: any stasis, meaning the urine stops moving, or any reflux back up the ureters can lead to very serious kidney infections. That forward flow is absolutely vital.
Those spurts of urine finally enter the bladder, a muscular sac sitting down in the pelvis. Its wall is composed of a smooth muscle known as the detrusor muscle. This wall is quite literally designed to stretch and hold volume. When it's time to go, that stretching, or distension, sends a signal straight to your nervous system, which triggers micturition, the fancy physiological term for urination.
The final exit pathway is the urethra, which is a single, thin-walled tube. And back to that comparative anatomy point from earlier, in males, the neck of the bladder and the upper part of the urethra are completely encircled by the prostate gland. This structural layout is exactly why prostate enlargement can so directly and often severely impact urination.
Now, controlling the actual release of urine relies on two distinct mechanisms that you'll want to memorize. First is the internal sphincter. This guy is made of smooth muscle, which means it is entirely involuntary. You have zero conscious control over it. Your autonomic nervous system handles the whole shebang. In sharp contrast, further down is the external sphincter. This one is made of skeletal muscle, meaning it is entirely voluntary. This is the sphincter you are consciously controlling when you decide it's appropriately time to void.
All right, let's wrap things up with Section 6, our quick recall summary.
Let's lock in everything we've learned today with a rapid-fire recap. The system relies on 4 pillars: 2 kidneys, 2 ureters, 1 bladder, and 1 urethra. The nephron is your functional unit, handling filtration, reabsorption, and secretion. Remember that filtration path: Glomerulus to Bowman's capsule, down the PCT, through the loop of Henle, up to the DCT, and out the collecting duct. Your kidneys are absolute units, filtering around 113 to 142 liters of blood for just 1 to 2 liters of urine. The ureters use peristalsis in 10 to 15-second spurts to move fluid actively. And voiding uses a 2-sphincter system. Internal is involuntary, external is voluntary. I want to leave you with this final provocative thought. If our kidneys have to filter well over 100 liters of blood every single day just to maintain our internal chemistry, what happens to our entire bodily system when even a single structural pillar in this pathway fails? Homeostasis is a delicate balance, and it relies on constant, uninterrupted flow. I encourage you to use this explainer as a jumping-off point to look deeper into renal pathology. Thanks for tuning in to AllAboutRx. Don't forget to check the links in the description for more high-yield notes. Hit subscribe, keep studying hard, and I'll see you in the next explainer.